Moving right along, so we just finished the 1.1 section. We'll move on to 1.2, which was energy sources, mostly revolving around circuits. So number 1. 1A, I should say. So use Ohm's law. Ohm's law is I equals V over R, which means a larger voltage gives you a larger current, but a larger resistance gives you a smaller current. Now you can rewrite this several ways. V equals IR, or resistance equals V over I. It's all the same equation, rearranging it. So in part A, we know the resistance is 470 ohms. We know the current. Actually, we don't know the current. We want to find the current. We know the velocity is 3.5 volts. So again, I equals V over R. I equals the voltage, we said it was 3.5 volts. The resistance was 470 ohms. And grab a trusty calculator. 3.5 divided by 470 is 0.00745. We'll round it off there. 0.00745 amps. Or I could more easily write that as 7.45 milliamps. That's A. Let's do B in red, just for kicks. B, we don't know the resistance. So resistance is unknown. The current is 15 milliamps. And the voltage is 6 volts. Now be careful when you plug this in, because this is milliamps. So that's equal to 0.015 amps. Alright, so resistance is voltage over current. If you wanted to plug it in the other way, because you don't have that written out separately, you could always start from V equals IR, plug in your voltage, 6 volts, plug in your current, 0.015 amps, times resistance. You're dividing by 0.015 because you want to get resistance by itself. That cancels out. I gotta do the same thing on both sides. Algebra is everywhere. So I have the resistance equal to, trusty calculator, 6 divided by 0.015 equals 400 ohms. Leave it at that. Moving on to the third one. Do that in green, just for kicks. So we have a resistance of 330 kilo ohms. 330 kilo ohms. Current of 10 milliamps. So, what does the voltage need to be? That'd be a good question of, hey, I have this resistance for some product, some device. It can only handle 10 milliamps. What kind of voltage does it need? What type of power source do I need to design for that? So, V equals IR, current times resistance. Now 10 milliamps is 0.01 amps. Let's scoot that guy to the other side. 330 kilo ohms is 330,000 ohms. Be careful with the prefixes. So 0.01 times 330,000 would give us, trying to get that 330,000. Take 2 zeros off of that. So 3,300 volts, which seems incredibly large, but it was making up these numbers anyway. If you read this as ohms instead of kilo ohms and thought that K was a typo, then you basically divide this by 1,000, you would have gotten 3.3 volts, and that seems more reasonable. Maybe it was just a typo on the worksheet we had. But either way you thought about it, that would be the two things you would get.